All right, recording. So 4.3 is kind of where we left off last time. It is where we left off last time. We were dealing with exponential functions. And if you remember last time, we made the bases the same. Here is the base. This is called the base. And this is called the power or the exponent. And what we did was 25 is really 5 to the second power. Once we made the bases the same last time, we said the powers should equal, and yes, they do in this case, okay? So that's just what we did last time. Now, this time, we're changing. By the way, this is called exponential form. We're changing exponential form to something called logarithmic form, log form. Now the book uses different letters. Let me just do this. A to the B power equals C. I think the book uses different power letters, but that's okay. I mean, this is my formula for exponential form, where A is the base, B is the exponent or the power, and C is just a number or the answer, whatever you want to call it. So log form, this is exponential form. To change it to log form, you have to change it. I'm going to put the formula down here. The log of A equals C and B. This is log form. If we call this exponential form, we call this logarithmic form. Logarithmic form is just a way of showing those exponential graphs. This is another way of looking at it. So A is the base. That's the base. B is the power, the exponent. And C is just the number. So it says write the logarithmic form for this. This is exponential form. So we're going to write it in log form. Let me change my color. In other words, we're just going to make it look like this. We're going to put a log in here. The base is 5. The answer is 25, and the power is 2. So 5 to the second power equals 25. That's called exponential form. To change it to the log form, this is what it looks like. And the way I always say it is 5 to this power equals this number. Log 5. This is a subscript. So you'll see that when you're doing the homework, that's a subscript. It's a lower, it's not a power, it's a lower level. So we're going to do the same thing here. Change. This is exponential form. We want to change it to log form. The base is 2. So it has a subscript 2. The answer is 1/4. And then the power is -2. That's it. We're just changing it to log form. They both mean the exact same thing. This is called exponential form. This is called log form. Let's try this one. Change it to log form. The base. Maybe I should have said base is B. A to the B power. We're calling this the exponent, B power. And this is no, wait. It's a x to the third power. This is the a. This is the b, sorry. And we're calling this the c. And I'm using this formula up here. So there's a, there's b, and there's c. Let's try something on our calculator. So if you want to double click, I think you can double click the calculator. Let me see how that works. Can I just make it bigger? On my calculator, I have a log button somewhere. Help me find something that says log. Oh, I found it. It's right there. Now your calculator does log, and it automatically does log base 10. So I want to put this. I'm sorry. Let me change my color. I want to put this in my calculator. Just this part. By the way, our calculator does log base 10. So when I hit log, there's automatically a base 10 that subscript there. You don't see it in the calculator, but there's automatically a 10 in there. There's automatically a 10 in here. And then we put 1,000 in there. 1,000. Okay. Do you see? I have log 1,000, and it has a base 10. It's just automatic. When I hit enter, it should equal 3. And it does equal 3. I hit enter, it equals 3. So do you see, if we look at this, 10 to the third power equals 1,000. So you could change that a little bit. Say 10 to the third power. So instead of using exponential form, we can change things to log form. You could go either way. Exponents and logs are the same thing. If you look at a log graph, it'll look really similar to an exponent graph because they can be changed back and forth. All right. So we want to change it again. Let's write down the formula I wrote down. I actually think, where's that formula sheet? We have a formula sheet, and I should be using the letters that the formula sheet has. Don't we have a 1314 formula sheet for this somewhere? Let's see. 1314 math formulas. I don't see this particular one in here. You would think it would be in here, just the standard, so we're using the same thing. All right, well, we have something like it. So don't forget, I'm going to write it up right. Let me raise this up a little bit. I'm going to write our formulas down again. I hate changing the letters now that I've already did. I already said a to the b power equals c. By the way, is that what I said the first time? Anybody? The log of a.
Yes, sir.
Yeah. Okay, equals b. So this is exponent form, exponential. And this is log form. So we have things in log form now. They want us to change them in exponential form. So if you want to, if it helps, label each letter, each of the numbers. This is A, this is B, and that right there is C. Now we just change it to exponential form. A to the B power equals C. And I would try that on your calculator, you know. Might as well. 4 raised to the 5th power on my calculator does say 1024, 1024. I put 1025, but it's 1024 right here. So 4 to the 5th power does equal 1024 when you hit enter. All right. And we're going to be using this changing from exponential to logarithmic or logarithm to exponential to solving for x and stuff. So once again, let's change this. This is A, this is B, and this is C. So it should be A to the B power equals C. And you just verify these on your calculator. 64 raised to the 1/3 power. I'm going to put the power in parentheses. 64 raised to the 1 divided by 3 power. And you can see it equals 4. It's not that we're doing any calculation here. We're not. All we're doing is changing one form to the next. I just wanted to show you on your calculator that they do equal each other. I mean, they're the same. They're just different forms. All right, let's try number 6. And I think we have quite a bit today. Number 6, changing the form. There's A, there's B, and there's C. 8 to the 3rd power equals 512. That's it. Just change it to exponential form. Log form, exponent form. Anybody have any questions? Don't forget just to step in, yell it out. All righty. Now we're going to do finding some answers. Let's see what we got. If I can get it up. There we go. All right, so we want to find these answers, the log 3 1/3. In order to do this, step 1, the first step I would do is change it to exponential form. So to solve for x, and that's what we're doing here, we're solving for x. Step 1, change to exponent form. So this problem is, and in other words, see, we want to try to find out what it equals. Do you see? We're trying to find out what it equals. If we don't see anything there, we say this just equals x because we're trying to find x here. Log 3 1/3 equals something. So let's change it to exponential form. Remember, this is A, this is B, and this is C. To change it to exponential form, it's 3 to the x power equals 1/3. That's not the answer now. We have to find x, but that's the first thing you do. Change it to exponential form. Step 2, we already know step 2. We have to make the bases the same. This is what we did last time. Make the bases the same. I can change this problem, 3 to the x. My base is 3. So I can change 1/3. By the way, remember 3 is a power of 1 here. If I bring it to the top, it's now 3 with a power of -1. Right? If 1/3, 3 has a power of 1. 3 to the 1 power is 3. If you bring it to the top so the bases are both 3, then when you flip it, you have to change the sign so it's now a negative power of 1. Once the bases are the same, step 3, the powers have to be the same. Powers must equal. So we're going to say these two equal. X equals -1. And that's my answer. It says evaluate the logarithm, find the answer, and the answer is -1. 3 to the -1 power equals 1/3. And let's verify that, right? That if x is -1, I'm going to put -1 here. 3 to the -1 power on my calculator. Let's try that on the calculator. 3 to the -1 power. 3 raised to the -1 power. And do you see it equals 1/3? That negative flips the 3 down to the bottom and still attached to the 1 to it. 3 to the 1 power is 3. If the 3 goes to the bottom, there has to be something on the top, and we just leave the 1 up there. All righty. Let's do the next one. So I'm going to do number 8A. 8A, we want to find x. It doesn't tell us the x, but we want to find x. By the way, anytime there's a well, let's solve this first. Change it to exponential form. It's a to the b power equals c. 10 to what power equals 1? I can't get the bases the same. But you have to know. You have to know. This is one of those that we talked. I think we talked about this. Yes, we did. Just briefly. On your calculator, try 10 raised to the 0 power. You get 1. Remember, and I could have did 8 raised to the 0 power. You get 1. 5 raised to the 0 power. You get 1. Anything raised to the 0 power other than 0 is 1. So something to some power equals 1. B has to equal 0 in this case. What we call B, but in reality it's X. We're X. So the answer is 0. All right. So we're finding what log 10 1 is. By the way, let's do our calculator again. Anytime you have a base 10 log, I'm going to erase everything. Anytime you have a base 10 log, you can plug these straight into your calculator like this. Remember, 10 is understood. So when I go to my calculator and I hit the log button, it's telling me that there's log with the base 10 already. So the log of 1 and with a base 10, it's there automatically. When you hit enter, it equals 0. So this one, you didn't have to do anything other than plug it in a calculator. The answer, oh, sorry, the answer is 0. The log of 10, see, 10 to the 0 power equals 1. All right. And you can't do that if the base is not 10, by the way. See, the base is 9. The base is 1/4. You can't just plug it in a calculator. You can only plug in base 10s into your calculator. Plug this in the calculator, see what it says. I think the answer is going to be 4. Log of 10,000. Log of 10,000 equals 4. So anytime you have a base 10, you can plug it straight in your calculator, or we can skip the exponential form. Let's say we don't know the answers for, and we just put x. 10 to the x power equals 10,000. Well, 10,000 is, change it to base 10, is 10 to the 4th power. 10 times 10 times 10 times 10. When the bases are the same, now the powers are the same. X equals 4. You see, either way, we get x equals 4 for number 9. All right, B. We're going to say we're trying to find x. We're trying to find what it equals, what this thing equals. So it's the base, 1/4, to the x power equals 64. Well, 1/4 is 4 to the -1, and then we still have an x power, right? We just changed that. We brought the 4 up to the top. It's a 4 with a power of 1 down here. When you bring it to the top, it's a -1 power. 64, if you try it on your calculator, is 4 to the 3rd power. 4 times 4 is 16. 16 times 4 is 64. We can still mess with this a little. Power raised to a power we talked about last time, you multiply. So this is 4 to the -1x, or -x power. -1 times x is -x. Since the bases are the same, then -x equals 3. Then the tops equal each other. I have to take the negative to the other side by dividing by -1. And x equals 3 divided by -1 is a -3. So for this particular problem B, the answer is x equals -3. Okay. Okay, let's try this one. 9 to the x power equals 0. So once again, a to the b power equals c. A to the b power equals c. 9 to the x power equals 0. Try 9 to the 0 power. That equals 1. 9 to the -1 power, that equals 1/9. There is no way of getting 0. When you have a number raised to a power, there is no way of getting 0. Even 9 to the 0 power equals 1. So you cannot, in a log form, you cannot have this answer as 0. So there is no solution here to this problem. So you just have to remember that. You don't have to remember it. You can even try to mess with it. How do I find out what x equals? Well, you can't. 9 to any power will give me a number. It's always going to be a positive number. So it can't equal 0, even though it says it's supposed to equal 0. So there is no solution here. Also, let's try B. 2 to the x power equals -5. There is no answer to where I can get a negative. Do you see? This c, this number that we talked about in log form, log a c equals b, I need you guys to understand this c is just a number, it's not a power. This c must be greater than 0. It cannot be negative. A negative number is impossible. And I'm going to kind of show you that right here. The log of -5. Remember, when I do log of -5 on my calculator, it's base 10. So it's 10 to what power equals -5? Let's do log of -5 on my calculator. Log, let's turn it on. Log of -5. Do you see how my calculator says error? You cannot take the log, even the log of 0, log of 0. The C part, the part that you're going to take the log of, the C, not the base, the C must be greater than 0, must be a positive number greater than 0. If you have a negative, then there's no solution. There's no answer that you can put in there to get a negative answer or a 0. So C cannot be negative or 0. It must be a positive number. It can be a small positive number, but it cannot be negative and it cannot be 0. So let's try this. By the way, there's another way of doing those problems, but I like the way we just did them. I think I'm going to go back and show you the alternate way of doing this problem, because it's actually on our formula sheet. So on our formula sheet, by the way, I'm looking at this formula sheet, the one that says Math 1314 formula sheet. And then I'm looking down here at the one that says change of base formula. Change of base formula, log here. So I'm looking at our formula sheet that says Math 1314 formula sheet. And we're looking down here at the change of base formula. So the change of base formula says log, see, they use different letters already, B and M. So this is the change of base formula. Log B of M equals the log of M divided by the log of B. So the log of the top number divided by the log of the bottom number. So here on our calculator, we're going to take 2 logs, since we can put logs base 10. And they're talking about these invisible base 10s, so we can do this on our calculator. The log of the top number, 1/3, divided by the log of the bottom number, 3. So let's put that in our calculator. On my calculator, I'm going to hit fraction. I'm making this a little bit. You can actually make your calculator, my calculator window, bigger. I'm going to hit the log of 1/3, fraction 1/3, arrow over, close, and then I'm going to do the log of 3. This is called the change of base formula. So you put it straight in your calculator and it's going to give you the answer. And we got -1. Remember for 7a, we got -1? This equals -1. Okay, so you can do that for each of these. Here, the log of the top number divided by the log of the bottom number. Let's try that really quick. Fraction, log of 1 divided by the log of 10 equals 0. And that's what we got. All right, let's try one that said error, that was not possible. There's no solution. We said no solution for this. So the log of the top number divided by the log of the bottom number on my calculator, fraction. The log of the top number, which is -5, divided by the log of 2. And when I hit enter, it says error. In other words, error means there is no solution. And if you go up one, that problem also has error, no solution. Okay, so you can do those both ways, either way I showed you. This is called the change of base formula, and it's on our 1314 formula sheet. And if you don't have this, don't forget, I gave you each one, but it's in the module somewhere. I can't remember which module I put that formula sheet there. Maybe we'll look at it later on, find it for you. All right, number 10, solve for x, the same thing. So the steps are the same. Step number 1, change it to exponential form. There's a to the b power equals c. A to the b power equals c. 9 changes to 3 to the second power, right? Once the bases are the same, then the powers equal each other. Or once the powers are the same, then the bases equal each other. That brings up a really good point. I can change my power to be the same. See, they're not the same right now. The powers are not the same. One's positive, one's negative. Oh, that's supposed to be a positive 2. So I want the powers to be the same. I can change this power to a negative if I flip the 3. Now the 3 is on the bottom. Do you see that? If I put a negative there, whatever that power is attached to gets flipped. The negative just flips it. The 3 now goes to the bottom and the 1's on top. 3 in a fraction form is 3 over 1. If I put a negative there, it flips, and this is what I get. If the powers are the same, then the bottoms are the same. X equals 1/3. All right. Next problem. The base to the power equals the answer, C. A to the b power equals C. Well, or X. Let's just use the letter X. I changed the letters. We're done. To find X, you just take 4 to the third power. 4 to the third power is 64 on my calculator, and X equals 64. 4 to the third power equals 64. All righty, moving on. Any questions? Just let me know. All right, so we're going to get a little bit crazier, but it's the same thing. This is A. This is it's kind of hard to see, but it is a subscript. That is A. This is B, and this is C. So A, this is A to the B power equals C, right? Do you see? A to the B power equals C. We change this to exponential form. A, this is A, that's B, and that's C. x minus 5 to the 1 power is the same thing as saying x minus 5. 7 to the 1 power is 7. 9 to the 1 power is 9. So x minus 5 to 1 power is x minus 5. So when we change this to exponential form, we got x minus 5 equals 10. Take the 5 to the other side. It's a minus 5, so we add 5. And the answer is 15. 15 minus 5 is 10. 10 to the 1 power is 10. Do you see? If I'm checking my work, if x is 15, if I put a 15 in here, I have log 15 minus 5 is 10. 10 to the 1 power does equal 10. All right. Let's keep going. I think I like classrooms better. I can pick on you. You guys are so quiet. All right, let's change this to exponential form. The base.
We're still here.
Thanks. To the x power. I actually have done many of these chats in the past when it was voluntary to come to class, to the online chats. I've done many of them with nobody there, so it's like I'm just rambling on. 3 to the x power equals 1 over 27. So, I mean, we change it to exponential form. This is what it is. We need the bases to be the same. If I bring the 27 to the top, it's 27 to the negative 1 power. However, 27 I can change to a base 3. We need to try to make the bases the same. If you check your calculator, 27 is 3 to the 3rd power. 3 times 3 is 9, times 3 is 27. So 27 is 3 to the 3rd power. Anybody know how I can stop these news feeds from coming up on my calculator? I can't get them to stop. And we talked about if you have a power raised to a power, you can multiply those. 3 to the x equals 3 times negative 1 is 3 to the negative 3 power. If the bases are the same, then the powers are the same. X equals negative 3 is the answer. And sure enough, 3 to the negative 3 power, if we did this is negative 3, 3 to the negative 3 power does equal 1 over 27. And we'll verify that on our calculator really quick. I got my document camera, so it's making it a lot easier with the calculator for me. 3 raised to the negative 3 power equals 1 over 27. Going on to the next problem. 14. How many problems are there? It's never going to end. Oh, it's real. Okay. 22. So number 14. So let's change it to exponential form. The base is 1/4 to this power equals x plus 51. You see, a to the b power equals c. This negative flips the 4, so it's now the 4 comes to top. It still has a 3 power, but once you flip it, the negative disappears. Or if it's positive and you flip it, then the negative appears. 4 to the third power equals x plus 51. Well, 4 to the third power is 64. We were trying to find x. You know, we're solving for x. Get the 51 to the other side by subtracting 51. And x equals 13. Not bad. All right, now we're going to do some graphing. Let's graph this thing. Now, I hate that they call this x. Well, they called it x, and so this is y, right? No, that's fine. I think we're okay here. If they call this x, then this is y. Another way of writing this is y equals log 3x. F of x is changed to y. Now, I'm going to change the y to the other side. It says y equals this. Let's have log 3x equals y. Okay? I think it's easier to read this way. So this is the same thing as this. I just took the f of x or the y to the other side because this is our form. This is log form, and I want to change it to exponential form. So remember, a to the b equals c. 3 to the y power equals x. This is my exponential form. This is what I'm going to graph. You can't graph this log form. I mean, you can plug numbers in there and on your calculator and all, but I'm going to use this. So from here, from this changing it to exponential form, I'm just going to do a t-table. Now, normally you would plug numbers into x and find y, but I think it's easier to plug numbers into y and find x. If y equals 0, here's y. If I put a 0 in there, what does 3 to the 0 power equal? On your calculator, if I put a 0 in for y, what does 3 to the 0 power equal? Anybody that's awake? Nobody's awake. Okay, I'll do it on my calculator. I've already done it several times.
1.
Yes. I've already, so thank God you didn't force me to do it. Anything to the 0 power does equal 1. Do you see? I'm just plugging numbers into y. So I'm going to plug 1 into y. It doesn't matter if you plug it into x or y. It's easier to plug it into y. 3 to the 1 power is then x equals 3. If I put a 2 in here, 3 to the second power, 3 times 3 is 9. So I have 1, 0, 3, 1, 9, x value 9, 2. Now let's plug some negative numbers in here. I'm going to just stretch it out here. What if I put negative 1 in here? So let me erase that. And into the y value, oh, not the x value, I'm sorry. I'm plugging it's so much easier in this case to plug it into the y value. If I put a negative 1 here, 3 to the negative 1 power equals 1/3. If I put a negative 2 here, 3 to the negative 2 power on my calculator says 1/9. Do you see? So I have x is 1/3, y is -1. 1/3 is about right here. -1 is here. X is 1/9, really close. It goes all the way down to -2, and so on. If you keep on going, it gets 1/27, 1/81. So the graph never crosses, but that's what it's very similar to an exponential graph, right? Except it's flipped. Well, that is an exponential graph with a negative power. So that's what we get for this graph. So we just wanted to plug some numbers in there and then try to graph it. You need some positive numbers, some negative numbers into y, and we had to graph it. Now the domain, what can x equal? Remember, I already said this is what the true C is. X cannot equal 0. Remember, I said x cannot equal 0, and x must be a positive number. This value, C, must be positive. It can't be negative. Do you see there are no negative x's? There are no negative c's, you know? And it's 0, it can't be because it says error on my calculator. So the domain starts right after 0. It doesn't equal 0, right after 0, and goes all the way to infinity. That's the domain. Now the range is how, the domain is how far to the left. It goes really close to 0, but it doesn't touch 0. And then it goes all the way to infinity. The range is how low does it go? It goes all the way down to negative infinity. And how high will this go? Well, this thing keeps on going up at a slow rate, but it keeps on going up. So the range goes from negative infinity to positive infinity. The domain is just from 0, but not touching 0, and it keeps on going to infinity. So let's see if we can graph anymore, if they want us to graph anymore. All right, so let's change this to exponential form, and I'm going to call this y. Once again, you can put the y here, but it's easier for us to put the y on this side, so we can change it. 2 to the y power equals this, x minus 1. So I'm just going to put some numbers in here. Let's start with, and we're going to plug the numbers into y again. I think it's easier if you plug it in the y. Let's plug 0 into y. So 2 to the y value equals x minus 1. If I put 0 in here, 2 to the 0 power is 1. Bring the x to the other side by adding 1. And x equals 1 plus 1 is 2. You see, if I put a 0 in here for the x, if I put a 0 in here for the y, I keep on forgetting we're plugging in the y's. If I put a 0 into the y, 2 to the 0 power is 1. Bring this 1 to the other side, and 1 plus 1 is 2. The x is 2. Okay, so I'm going to plug another number in here. I want to plug in y to the 1 power. 2 to the 1 power is 2. Take the 1 to the other side by adding 1. If x is 1, I'm sorry. No, why do I get that confused myself? It really is confusing. If y is 1, right, we plugged 1 into the y spot. Remember, this is the formula. That's the y spot. If I plug 1 into the y spot, if I plug 1 into the y, x is 3. Let's try another one. Let's plug, I'm going to write it down this time. Let's plug 2 into the y spot. If I plug 2 in here, 2 to the 2nd power is 4. 4 equals x minus 1, bring the 1 over, add 1, x equals 5. So let's graph these points. 2, 0, 3, 1, 5, 2. Oh, that's not 5, 2. That's 4, 2. 5, 2. And I'm going to do one more. Let's plug 3 into y. What happens when you plug 3 in there? 2 to the third power. 2 times 2 times 2 is 8. Bring 1 over. 8 plus 1 is 9. So x is 9. Y is 3. All right, so it looks like our graph is like this. So now I'm going to try to get 1 and 0 in there. Well, I'm going to go to the other side. We plug 0, 1, 2, 3 in there. Let's try a y of -1. And or yeah, this is going to get a little crazier. If I put a let's put a -1 in there. 2 to the -1 power. I'm going to use decimals in this case. 2 to the -1 power is 0.5. Bring the 1 over by adding 1. X equals 1.5. So if I put a -1 into the y, then x equals 1.5. 1.5 and -1 is here. If you keep on continuing, your graph goes like this. Okay. And you can keep on going. I mean, you could put a -5 in there and then add 1. Actually, no, it doesn't. That brings up a good point. I'm sorry. No, I should have did some more points. I wanted to show you what happened here. Let's do another point. I'm going to get crazy. I'm going to put one more point in here. Let's put -8. So I'm going to put, my x and my y's. If I put -8 into the y spot, and I'm going to put it on my calculator, you're going to see what happens. 2 raised to the -8 power equals 1 over 5, 1 over 256. And then if you bring the 1 over by adding 1, you get 1 and, you get a really small number. If you take that to a decimal, it's 1 point something, it's a very small number. I'm not exactly sure, but it's a really small number. So if x is 1 really small number, y is a -8. There we go. So this doesn't go to 0. It hugs 1. It doesn't pass 1. In other words, there's an asymptote that goes right through 1. It doesn't cross 1. How do I know that? You look, this -1 means the graph moves over to the right 1 spot. So it doesn't hug y equals 0 or x equals 0. It hugs x equals 1. That -1 on the inside moves the graph to the right 1 spot. This was original, the one we had before. It hugs the line here. but this -1 moved the graph over to the right one spot. Remember, minus on the inside moves it to the right, and plus on the inside moves it to the left. So that's kind of cool. All right, so we have more problems. Let's see what we're going to do with these. Let's change them to exponential form. And you can call this X or Y, whatever you want. 2 to the X power 2, this is A to the B equals C, right? A to the B equals C. 2 to the X power equals C. If the bases are the same, the power is equal. That's a pretty easy one. X equals -5. Now this other one here, there is a rule, property of exponents. So you need to go to your formula sheet again, and the formula sheet all the way down here. I mean, I would just put a little check mark. It says property of exponents, and they give you this formula. Oh wait, that's the wrong formula. I need to go to logs because this says a log, a power of a log. Here it is, properties of logs. So I'm on our formula sheet, and I'm going to go to properties of logs, and it's this one right here. So I'm going to write that one down. Properties of, you want to look on your sheet to find one similar. And on my sheet it says A to the log power base A equals M, then equals M. So this is the formula, A log A M. So in other words, do you see how these two are A's? This is the M. So if you have all this we do right here, the answer is just M. The answer to this problem is 1.7. And that's from our formula sheet. Our formula sheet says if you have a problem that looks like this, the answer is going to be whatever's right there, the M. And I do have a problem like that. The A's are the same. Then I have a log. Whatever the answer is right there, 1.7. And that's on our formula sheet in the properties of logs, and it's right there. Cool. Let's move on. It says use the properties of logs to rewrite the expression, simplify the results if possible, assume the variables represent positive real numbers. Okay. So there's a couple of questions like this on the test. And in the homework. So you properties of logs, once again, we have to go through these properties of logs. Here's and then we're going to go through properties of logs. It says if you have a log and things are multiplying inside, you can separate them. So let me just show you some of these properties on the side. It says if you have a log and any base, it says M times N. If you have two things multiplied, 2 things, 3 things, 4 things, you can separate this by having log A M and then log A N. See, when you have multiply, you change it to two separate logs that are adding. That's one of the rules. Then you have this next rule. It says log A MR changes to R log AM. In other words, it says if you have a power, you can bring it down in front of the log. If you have an answer in part C, if you have a power in part C, you can bring it down in front. That R was here, now it's out in front. Just like we had multiplying changes to adding, if we have a log A M divided by N, it can be changed to two different logs, log AM and log AN, but you subtract it. When you divide, you subtract. When you multiply, you add, change it to add, but when you divide, you change it to subtract. You could break it into two different logs, but you're subtracting them. Okay? So these are properties of logs. And we're going to use the properties of logs to expand these expressions, rewrite the expressions. And normally on the test or homework, it says, what is the expanded form? So, this, I have actually three things multiplying. So this changes to log A. Multiplying means we're adding log A. It means we're adding log A. We're multiplying three things. First, we're multiplying a 7. Then we're multiplying an x5. Then we're multiplying a y. Do you see? When we have multiplying between expressions, we change it. When we have multiplying, we change it to add. Each individual one add. We're not done. If you put this down as an answer, it is wrong because you cannot have this power. We remember the power. If you have this power, the power comes in front of that particular log. So the correct answer for this problem is log A7 plus bringing the 5 in front, log AX, because the 5 goes in front, plus log AY. So you have to use all these logs, and now it's fully expanded. That power needs to be put down out in front of that particular log. All right, so let's try it again. Next problem. If I have a fraction that's dividing, I change it to two logs that are subtracting. Log base 15, first I have 2m, and then I have an s. I think that's an s. I'm going to put my s's like this. And there's no powers or anything, so we're done. So when we divide, we change it to expand it to subtract. Oh, sorry. There are three things. Look at that. That's multiplying. I still have multiplying here. I have to break that up. Multiplying means add. So this is log 15. Log 15. We have a 2 here, and we have an m here. Do you see? We have to break this up into 2. And then we still have a subtraction, log 15s. I'm going to leave it like this. Normally, since this is separate, I would put that in parentheses because the whole thing is subtracted by this. So this is how I would leave it. I think either way, either expression is fine with the parentheses or without the parentheses. But I like the parentheses there, but it's not required. Mathematically, it's not required. Okay. Number 20. I didn't think we were going to get to all these. Guess we did. Good. So we're going to expand this. The top is multiplying. So first we're going to have log 3 plus log 3. And then we're going to have a subtraction. Log 3. I said subtraction. I actually think we do need it. Since the top is multiplying separate, I like to keep that top in parentheses, and then it's divided by log 3. So it's x to the 4th, y to the 2nd, and this is 8. And we have these powers here. Sorry, I made this kind of messy. Y squared. There we go. And don't forget, you can't have powers when you are in expanded form. You have to bring the powers in front. So this is 4 log base 3 to the x power. And this goes to the front, the 2. 2 log base 3 to the y power minus log 3, 8. Okay? Now, if you put this down as your answer, you're going to be wrong. What? Because of this over here. Try to use that change of base formula we said on your calculator. Log 8 divided by log 3. Remember, it was the log of the top divided by the log of the bottom. Put that in your calculator. Log, where is it? Log of 8. I need to make it bigger so I can see it on my screen. Divided by the log of 3. Or you could put it in fraction form, either way. And do you see, oh, it's not, what did I just do? Oh, no, that's fine. Is that the right numbers? Are we doing log? Yeah, we are doing log of 3. Never mind. Well, no, this brings up a good point. Do you see how the answer is a decimal? So if the answer is a decimal like that, that brings up a good point. I thought I was dealing with a 2, base 2, but it's not, because 2 to the 3rd power equals 8. If the answer is a decimal, then we're done. You don't change it. If the answer was a whole number, you would change it. So this is the answer. That is the expanded form. And I think we'll get to an answer of, maybe we'll get an expanded form where that changes. But I thought that was a whole number. I thought it was log 2 to the 8th power, and 2 to the 3rd power equals 8. So that would have been an equal 2, but it doesn't. It equals a decimal, so we leave it as it is. Good. All right, 2 more. I think it's 2 more, or yeah, 2 more. Write the expression as a single log, assuming all variables represent real numbers. So first we have this, and then we have this. So it says write it as a single. That means we want to squeeze this together. Don't forget, if I have a power out in front, that's really the power of the x, log a x to the second power, minus log a to the y. If there's a subtraction, that really means I have a division. I have a log a on top. I have a log a on the bottom. On top, I have an x squared. On the bottom, I have a y. And we're done. So when you're in when you combine it, you could write it like this, but I think your computer would mark it wrong. By the way, we're combining it into assume all variables. Write the expression as a single logarithm. We have two logs here. Do you see? It's the same thing as writing log a and then a fraction. The x squared comes on top and the y goes on the bottom. So this is the correct way of writing it. It's, by the way, it's the same thing, but they want it as a single log. So log a with a fraction, and it's a fraction because of subtraction. Subtraction means fraction. Log base a x squared to the y. And the way I was doing with parentheses is correct because number 22 has it like that with parentheses. So that means that when you have a parentheses, that means that's all together. It's either on the top or the bottom. Wherever it's all together, it's going to be all together like that. So number 22. We're going to write it as a single log. So it's going to be log a. There's a subtraction here, and it's t over s. You see, it's t divided by, or subtraction, s. Subtraction means s. T over s times, and since this is in front, it comes over to the top, times u to the fourth power. So this becomes log a base a t over s u to the fourth power. So it's one expression. Here, there's an invisible multiply. Here, there's a divide. So, and once again, since this is in parentheses, it's just saying, this part here was in parentheses. It's just saying, hey, this is an expression all by itself. And then you're going to multiply it times this, times that u to the fourth power. All right, that's it. That's all I had today. Did anybody want to ask any questions?
I don't have a question, but I do want to say thank you for sending out that email about the survey for student research. I'm not sure if everybody on here got the email. That's actually for student research for the Advocacy Center for our English 1302 class. If you guys could fill out that survey, and it's anonymous, please.
Yeah, that survey I sent everybody, they're doing that survey. This you say in the Student Advocacy Center. So if you haven't done it, just log into and look for that email I sent you, and just click on that link.
Yeah, we have to present our findings to the dean and the chair of the department. So if you could please fill that out. We need as many participants as possible. Now that we moved online, we were going to have everybody come in and do the I guess, usability research. But since we went online, now we have to do surveys.